Most people buy cheap close-up lens sets expecting clear macro shots, but they are often disappointed. Today, I am testing Vivitar filters against extension tubes, trying to achieve a true one-to-one macro image. Hi! Let's imagine you need to shoot a close-up or an insert, but the lens cannot focus close enough, especially on zoom lenses, where the minimal focusing distance leaves much to be desired. Today, we'll find out how to get these extreme close-ups on macro shots. If your camera can record in higher resolution that you need to deliver, you can always scale and crop the image. Any camera shooting in RAW that allows to record different resolutions actually just crops out the central area. It looks the same as cropping on post, but if you crop in camera, you will not only see the actual magnification, but also save some extra space on your recording media. There are plenty of devices that can help to shoot with higher magnifications, for example, macro lenses. I have a set from Vivitar that is called close-up macro lenses. So, is it close-up or macro? Let's dive into the theory. Let's say we have a coin 36mm in diameter. We shoot this coin on camera with a full-frame sensor like Pyxis 6K. The sensor width is also 36mm. If the projection of the coin is 10 times smaller than the real coin, in our case 3.6mm, this is called close-up. Its optical reproduction ratio is 1:10. If the coin on the sensor is 2 times smaller, it is called extreme close-up, and the ratio is 1/2. The shot can be called macro only if the object is projected onto the sensor in its real size or larger. That means the ratio is 1:1 or higher. To calculate the optical reproduction ratio, we need to find the coin width in pixels. I crop the image left and right until the borders touch the coin. I try to be precise, but a couple of extra pixels do not matter. Here we can see the amount of cropped pixels. To find the coin width in pixels, I need to subtract both left and right crop values from 1920, as I edit in HD resolution. Then, I need to find the camera sensor width in specs. For Pyxis 6K it's 36mm. To get the coin projection size on the sensor, we need to divide its width in pixels by 1920 and multiply it by the sensor size. Knowing the real coin diameter, we can calculate the magnification. Just divide the width in millimeters by the coin diameter. Now we can find the optical resolution ratio denominator. Simply divide 1 by the magnification value. I put all my crop values into Google Sheets, so let's fill in the formulas and do all the math there. Here I get the width in pixels. Converted into millimeters, I put the $sign in the formula, so when I expand it down the column, the sensor width value will be read from exactly the same cell. Then I calculate the magnification. Once again, don't forget the $signs. And finally the ratio denominator. The ratio for my lens is around 1/11. Not bad for a zoom lens. It's time to expand the formulas and to round up the results. The result even matches the data from a reference book. But is it a true macro, with at least 1:1 ratio? No. Vivitar close-up macro lens set comes in a soft pouch. There are 4 lenses in the kit, +1 diopter, +2, +4 and X10 macro. That is actually a +10 diopter lens. The lenses are stackable, but you cannot put +10 over +4, so the maximum you can get is +13 diopters. Let's see the test footage I've shot. Here we'll pay attention only to the magnification. The optical performance of the lenses will be discussed in a separate video. Just pay attention that you need plenty of light to compensate for the closed aperture, as the depth of field when shooting macro is extremely shallow. Consider using ring lights, as any other sources may cause flares if the rays of light fall onto the lens surface. Different lenses have different minimal focusing distances. For Zocata Ace 3580 it is 74 cm, and for Samyang 50mm it's just 45. As I don't have an EF adapter for my Pyxis, the following test will be performed at Blackmagic 4K Production Camera. Even on a clear lens, the coin looks much bigger. That's the result of using a more close focusing lens and a smaller sensor. We consider the sensor size in our formulas, so it will not affect the final ratio. Let's go back to the calculations. Even with no close-up lens attached, we have a 1 to 6.3 ratio, almost 2 times higher compared to a zoom lens. Now I expand the formulas to get the ratios for all the close-up lenses. Looks pretty good, but keep in mind that the sensor size and resolution are smaller, so it's possible to achieve similar results by cropping the 6K full-frame footage. Poor man process, remember? Is there a chance we can get higher magnification without a dedicated macro lens? The answer is yes, if you use extension tubes. The extension tubes, or macro rings, transform your standard lens into a macro one. The main difference is that unlike a dedicated lens, each tube gives you a discrete magnification boost. If you pick the wrong one, you need to take off the lens and attach another ring. I have an EF mount set, but the tubes are available for other mounts, including PL. They are stackable, so you can get extremely high reproduction ratios. I did my maths, and the results are much closer to the real macro. Here are the shots. As you see, the tubes add almost no distortions or aberrations. There are 3 main ways to get extreme close-up on macro shot. At first, dedicated macro lenses, that are probably the best, but the most expensive. Also, attachable close-up lenses. They are good at minor magnification ratios, but also they can add flares and extra distortions. And extension tubes, that are the most difficult to operate, but also they allow you to get the highest optical reproduction ratio and the lowest level of additional distortions. As you see, all of them have pros and cons, so choose wisely and subscribe for more.